years, Liopleurodon was the name that defined prehistoric ocean terror. A massive pliosaur, jaws lined with teeth the length of bananas, popularized by documentaries that estimated its size at over 20 meters long, larger than a blue whale, large enough to swallow a small boat whole. It became shorthand for the scariest thing that ever swam. The image stuck. Toy aisles, documentary specials, internet lists of prehistoric monsters. Liopleurodon shows up near the top of almost all of them, and for a long time, that 25-meter figure went largely unchallenged in the public imagination. But here's the problem. That number was never based on solid fossil evidence to begin with. And once you actually look at what Liopleurodon really was and what else was swimming in those same Jurassic seas, a very different picture of biggest threat starts to take shape. Let's start with Liopleurodon itself, because separating the real animal from the documentary version matters here. Liopleurodon lived during the late Jurassic, roughly 160 million years ago, in shallow seas that covered much of what is now Europe. It was a plesiosaur, a group of short-necked, large-headed marine reptiles built like a cross between a crocodile and a whale, with 4 powerful flippers, a torpedo-shaped body, and a skull packed with conical teeth designed for gripping and tearing rather than slicing. The famous 25-meter estimate came from a single 1999 BBC documentary, Walking with Dinosaurs, which extrapolated wildly from a partial jawbone. Actual fossil specimens, the ones paleontologists can confidently measure, suggest Liopleurodon was probably somewhere between 5 and 7 meters long. Still a formidable predator, still bigger than a modern orca, but nowhere near the boat-swallowing leviathan that made it famous. So if Liopleurodon was realistically somewhere in the size range of a large great white shark or small orca, that immediately changes the conversation, because the late Jurassic seas weren't some calm, empty ocean with one undisputed king. They were packed, densely packed, with multiple lineages of marine reptiles competing for the same prey, the same territory, and in some cases, almost certainly for each other. Consider Plesiosaurus, a genus that lived in roughly the same time and place as Liopleurodon, and in some cases grew significantly larger. Some Plesiosaurus specimens, based on skull measurements alone, suggest body lengths approaching 10 to 12 meters, nearly double Liopleurodon's realistic size. Pliosaurus had the same basic body plan, the same short neck, the same massive skull built for crushing force, but scaled up considerably. If you're looking for the apex predator of late Jurassic European seas, based purely on size and bite force among plesiosaurs, Plesiosaurus has a much stronger claim than Liopleurodon ever did, and it's barely a household name by comparison. But plesiosaurs weren't even the only major predatory lineage in these waters. Sharing the same seas were the Ichthyosaurs, a completely different group of marine reptiles that had evolved a body plan eerily similar to modern dolphins and tuna, long before either of those animals existed. By the late Jurassic, the biggest Ichthyosaurs weren't quite at their historical peak. Earlier Triassic and early Jurassic species like Shastasaurus and Shonosaurus had reached truly enormous sizes, some estimates pushing past 15 meters. But even the late Jurassic Ichthyosaurs remained fast, agile predators built for chasing down fish and squid at speed, representing a completely different kind of threat than the ambush and crush strategy of plesiosaurs like Liopleurodon. And then there's a smaller player that at first glance doesn't look like it belongs in this conversation at all. Hybodus, a genus of shark that patrolled these same Jurassic waters, typically reaching only 2 to 3 meters in length. On its own, Hybodus posed no threat whatsoever to an adult Liopleurodon or Plesiosaurus. But that's exactly the point. The danger Hybodus represented wasn't to the adults. It was to everything smaller, the juveniles, the newly hatched, the vulnerable early stages of every large marine reptile in these seas, including, eventually, Liopleurodon's own offspring. A predator doesn't need to be bigger than you to be dangerous to your species. It just needs to be bigger than the version of you view that's most exposed, and that exposure was constant because of how these animals reproduced. Marine reptiles, including plesiosaurs and ichthyosaurs, gave birth to live young in open water. Evidence for this exists in the fossil record for ichthyosaurs especially, with specimens preserved in the act of giving birth. But live birth in open water means newborns are immediately exposed, with no nest, no shelter, nothing beyond, at best, staying near the mother for a short window. In an ecosystem this competitive, a huge percentage of any given species population existed in a near constant state of being potential prey for almost everything around them, including animals like Hybidus that the adults of their own species would never need to fear. Now layer onto this the evidence of violence between the adults themselves. Many marine reptile fossils from this period show healed bite wounds, scars from attacks the animal survived, which means predator-on-predator violence wasn't rare. It was common enough to leave a fossil record. Plesiosaurs bit other plesiosaurs. Ichthyosaurs show bite marks consistent with attacks from larger plesiosaurs. This wasn't an ocean where each species stuck to its own lane. It was an ocean where being a large marine reptile didn't make you safe from other large marine reptiles. It just meant you were also simultaneously potential prey to something close to your own size. And then there's the geography, which made every part of this worse. The late Jurassic European seaway wasn't a deep, open ocean. It was a shallow, warm, island-studded sea, similar in some ways to a vast, sprawling version of the modern Caribbean, but populated by animals that, pound for pound, were far more dangerous than anything in the Caribbean today. Shallow water means less room to maneuver, less room to flee, and more opportunities for ambush predators to corner prey against the seafloor or against islands. For any animal living in this environment, regardless of its own size, the geography itself worked against escape. You weren't just dealing with the threat of one large predator. You were dealing with an environment engineered by accident of geology to make every encounter with anything larger than you more dangerous than it would be in open ocean. So when you ask what was worse than Liopleurodon, the honest answer isn't a single named species waiting in the wings to steal its crown. Plesiosaurus was bigger and occupied the same role with more raw power. The ichthyosaurs represented a faster threat plesiosaurs couldn't easily catch, and smaller predators like the hybidont sharks, while no match for an adult pliosaur, were a constant danger to the juveniles, the eggs, the next generation of every species in these waters, including Liopleurodon's own. Add to that a shallow, island-studded sea with nowhere to hide, and bite-mark scars on fossil bones proving that even the largest animals here regularly attacked each other and survived to bear the wounds. So the 25-meter monster from that 1999 documentary never existed, but the reality was worse. It wasn't one giant leviathan ruling the waves. It was a shallow, inescapable arena where every predator at every size was simultaneously the hunted. And that's far scarier than any fictional monster ever could be.